Welcome everyone to week 2. For week 2, we're going to be reviewing chapters 2 and 3. You're going to have discussion board number 2 and assignment number 1. Let's review some of the roles of the discussion board. First post due by Thursday. 2 peer responses due by Saturday night, as the weekend's on Saturday. Make sure in your initial post that you include both an in-text citation and a reference in APA formatting. So that's a big component. So for this week, we're going to look at chapter 2. And this chapter is going to look at a variety of things. This chapter is going to review the core ideas of the theory of probability that are needed to understand the regression analysis, which we're going to use a lot in the course, and econometrics. We assume that you've taken an introductory course in probability statistics. If your knowledge of probability is stale, you should refresh it by reading this chapter. If you feel confident with this material, I think you should skim through the chapter in terms and concepts at the end to make sure you're familiar with the ideas and notations. But this chapter is going to probably be more of a review for some of you. Most aspects of the world around us have an element of randomness. The theory of probability provides mathematical tools for quantifying and describing this randomness. Section 2.1 reviews probability distributions for a single random variable. Section 2.2 covers the mathematical expectation mean variance of a single random variable. Most of the interesting problems in economics involve more than one variable. In section 2.3 introduces the basic elements of probability theory for 2 random variables. In section 2.4 discusses 3 special probability distributions that play a central role in statistics and econometrics. The final 2 sections of this chapter focus on a specific source of randomness of central importance in econometrics. The randomness that arises by randomly drawing a sample of data from a larger population. For example, suppose you survey 10 recent graduates selected at random. You record their earnings, compute the average earnings using these 10 data points. Because you choose the sample at random, you could have chosen 10 different graduates by pure random chance. Have you done so, you'd observe 10 different earnings and would have computed a different sample average. Because the average earnings vary from one random sample to the next, the sample average itself is random. So when we look at all these random variables, make sure to note the importance of random variables. Because a lot of people get confused about how random variables are established and if any biases are noted in the random variables. Chapter 3 is going to be a little bit different. Chapter 3 is going to focus on a review of statistics. Statistics is the science of using data to learn about the world around us. Statistical tools help us answer questions about unknown characteristics of distribution in populations of interest. For example, what is the mean of distribution of earnings of recent college graduates? Do you mean earnings differ for men and women? If so, by how much? These questions relate to the distribution in earnings in the population of workers. One way to answer these questions would be to perform an exhaustive survey of the population of workers, measuring the earnings of each worker and thus finding the population distribution of earnings. In practice, however, such a comprehensive survey would be extremely comprehensive and very expensive. The only comprehensive survey of U.S. population is the census. The 2000 census cost $10 billion. The 2010 census cost $15 billion. You'll find that's very costly to get information. Very important. The key insight of statistics is that one can learn from a population distribution by selecting a random sample from that population. Rather than survey the entire U.S. population, we might survey, say, 1,000 members of the population, selected at random by simple random sampling. Using statistical methods, we could use this sample to reach tentative conclusions, to draw statistical inferences about characteristics of the full population. 3 types of statistical methods are used throughout econometrics: estimation, hypothesis testing, and confidence intervals. Estimation entails computing a best guess numerical value for an unknown characteristic of population distribution, such as its mean from a sample of data. Hypothesis testing entails formulating a specific hypothesis about the population, then using sample evidence to decide whether it is true or not. Confidence intervals use a set of data to estimate an interval or range for an unknown population characteristic. So in sections 3.1, 3.2, 3.3, you're going to review the estimation, hypothesis testing, and confidence intervals in the text. If you have any questions about this week, please let me know. If you'd like me to review your assignment that you're going to submit, let me know as well. But just note that all work must be submitted on time and cannot be submitted through email. I look forward to your effort.